School of Engineering Sciences, as well as an associate professor and founding head of the Department of Biomedical Engineering at the University of Ghana. She's also the founding head of the Department of Orthotics and Prosthetics at the University of Health and Allied Sciences, Ghana. She's a fellow of the Ghana Institute of Engineering, a fellow of Biomaterial Science and Engineering, a fellow of the Ghana Academy of Arts and Sciences, and an international fellow of the Royal Academy of Engineering, UK. She is noted for science and engineering education and has been the host and quiz mistress of the hugely popular Ghana National Science and Maths Quiz since 2006. She has been an invited speaker at numerous high-profile fora, both nationally and internationally, and has received a number of prestigious national and international awards. She is the founder of the Elsie Effah Kaufmann Foundation. Please help me welcome to the podium, Engineer Professor Elsie Effah Kaufmann.
Get your face ready for the problem of the day.
Thank you very much for the introduction. Engineer Dr. Muna, I don't think I'm going to give you X minus Y today. All right. Engineer Dr. Muna, President of Academic City University, distinguished guests, colleagues, educators, partners, and young minds who represent Africa's future. Good morning to everyone here.
Good morning.
I bring you warm greetings from the School of Engineering Sciences at the University of Ghana, and it's both a pleasure and honor to contribute to this very important conference. I'm deeply grateful for the invitation. Today I'm speaking on the topic, African reality, building a strong engineering pipeline from the basic level to career. Now let me begin by unpacking the various keywords in the topic, starting with engineering. And please, you will forgive me if my examples tend to be more biased towards Ghana. This is where I live, this is where I practice my trade most of the time. But I'll try to be a little broad in the examples as I move along. All right. So, people hear the word engineering, and the first images that come to mind are complex mathematical equations, tall buildings, and machines. Engineering gets labeled early. It is tagged as a subject for the exceptionally brilliant, highly technical, and reserved for a select few. By and large, it is seen as a field dominated by numbers, calculations, and complex designs. However, engineering is much more than that. At its core, engineering is about curiosity, a child asking why and daring to find a solution. It is about asking questions, exploring possibilities, and finding practical solutions to everyday problems. Engineering begins long before university lecture halls and professional laboratories. It starts when a child wonders why a bridge stands, how electricity powers a light bulb, or how water flows through pipes. So, Engineer Dr. Muna, ECG, a lot of engineering going on there, I hope. Now let's talk about our dear continent and the engineering pipeline. In discussions about Africa's future, we often focus on potential. Everywhere we talk about Africa and the future is about potential. However, potential without a pipeline is just a dream. Our continent is rich in resources, rich in talent, yet still imports crucial expertise. Why? This is because we have not been intentional enough about nurturing engineers. Building engineers start at the basic levels. Engineers do not suddenly appear in university. They are not created in their final year. They are nurtured. Nurturing starts from childhood. That's how engineers are made. It starts from the basics. In Ghana and most parts of Africa, science is often taught as theory, something to memorize, not something to experience. We are taught about electricity, not how to build circuit boards. This approach does not nurture our curiosity, and when this happens, potential is lost. Having a pipeline at the basic levels gives future engineers a clear pathway. Introducing practical science, technology, engineering, and mathematics STEM at the basic levels gives children the opportunity to not only ask questions but to experiment. They begin to see solutions to problems around them. So yesterday I was at the Helping Teachers Teach Mathematics conference. I was invited. I went there with no slides, no equations, nothing. But I went there to show them how they can teach mathematics using real life examples and doing real activities, experiential learning. At the end of the experience, one of my assistants said, I've never seen math teachers so happy. I've never seen them smiling. This says a lot because we have a phobia for some of the subjects that help us to do the engineering. That we can do things differently, can't we? Let's come back to building the engineering pipeline. Building an engineering pipeline cannot be left to schools alone. Industry must partner with educational institutions, engineers must mentor students, and communities must celebrate innovation. When young people see role models who look like them solving real problems, engineering becomes attainable. Additionally, we must remember that Africa's engineering must be contextual. Because our challenges are unique, our solutions must be tailored to meet them. The engineers we train must be equipped to solve African problems. This is why the journey from basic level to career must be intentional. It must be continuous and supported at every stage. Shall we now address the African reality? We must be honest both about our challenges and about our extraordinary promise. Africa is home to over 1.5 billion people, the youngest population on the planet, the fastest urbanizing continent in the world, and arguably the greatest concentration of untapped engineering problems on Earth. Infrastructure deficits, food insecurity, inadequate water systems, energy poverty. Sorry to be hitting this so hard, dear Chair. By the way, did you know that over 640 million Africans still lack access to electricity? The problem yet, Africa continues to face a severe shortage of qualified engineers. Sub-Saharan Africa has fewer than one engineer per 100,000 people, compared to about 500 per 100,000 in Europe. According to the African Development Bank, Africa needs approximately 2.5 million new engineers every year to meet its development targets. In the meantime, our universities are producing a fraction of that number. Worse, a significant proportion of those who do graduate either migrate abroad or end up working outside their field. Even more striking, Africa invests only about 0.54% of GDP in research and development, far below global averages. This is unacceptable. Okay, so let me tell you a story. Or let's start by reflecting on something. I I invite everyone here to find and visit a typical junior high school in our rural areas. Please do this exercise for me. A typical one, don't go to the high-flying ones, go to a typical one. You will most likely find a truly passionate science teacher. I have a lot of respect for our science teachers, you see. This science teacher will be teaching with chalk diagrams because the school will have no lab. There will be no lab there. The learners will be bright, curious, and full of questions. That is if you can get them to start talking. This is exactly what I saw when I visited my daughter, who was teaching at a rural junior high school in Accra, in the water region of Ghana some years ago during her national service period. I have since been in similar places and seen similar scenes elsewhere. On one such visit, a young girl asked me, "Auntie, can someone like me become an engineer?" Of course, I told her yes. But I left troubled. Because the answer should not depend on meeting someone like me. The answer should be built into the system itself. That is the gap we are here to address. The African reality is not a limitation, it is a launchpad. But only if we are intentional about building that pipeline. So at this juncture, permit me to link the reality to our engineering pipeline in 4 clear stages. Stage 1, the foundation, basic education. Walk into many of our public primary and junior high schools, and you can ask the class 6 people, who is an engineer? Too often the answer will be silence, or someone who repairs cars. It's not wrong, but it's not complete. By age 12, most of our children have never met an engineer, never seen a lab, never been told that the person who fixed the borehole in their town was an engineer. Worse, we punish curiosity. The junior high school girl in my hometown, Elsie, who takes apart her father's radio to see how it works, is more likely to be caned than celebrated in that moment. We did not discipline a child. We discourage an engineer. Our teachers are not to blame. You cannot teach what you have not been given. A junior high school science teacher with no lab equipment, no training kit, and 60 plus students in a class is being asked to build engineers with words alone. That is like asking a mason to build a house with a lecture on cement. Stage 2, the bridge. And here I talk about secondary and technical education. Here the pipe narrows. Students choose elective math and physics because they are good at them. But I cannot tell you why these subjects matter. We teach trigonometry as an abstract exercise, not as the tool surveyors use to map the relatively new term and the interchange. We teach coding, that is if we teach it at all, without showing how it can help a tomato farmer in Avungu track market prices. So students arrive at our university gates with grades but without purpose. They have passed, but they have not seen. And because they have not seen, many of our brightest avoid engineering altogether. Engineering looks difficult, foreign, and disconnected from Ghana or Africa. Reflect with me for a moment and let me recap. Ask a group of seniors what they think engineers do for a living. So I started by asking the junior high schoolers, right? Now senior high schoolers, let's see the improvement. The most common answer you're likely to get is they fix machines. Very few will connect engineering to the design of the mobile phones in their pockets, the roads beneath their feet, or the water system that supplies their school. When young people cannot see themselves in a profession, they do not pursue it. Visibility is as important as viability. Technical and vocational education and training, what we call TVET, must also be urgently rehabilitated. For too long, TVET has been treated as a second-class pathway, reserved for students who didn't make it academically. This is both wrong and wasteful. Technical education done well is the backbone of any industrialized economy. Germany, South Korea, and Singapore built their economic miracles on the back of strong TVET systems. Africa can and must do the same. Stage 3, tertiary education. This is where I've spent my own years, many of them, since I returned to Ghana in 2001. It's been 25 years, wow, how long? And this is where many of us teach. In Ghana, deliberate efforts are being made to expand STEM education. Engineering graduates are expected to rise from about 6,500 a year to 30,000 by 2030. But let's be honest with ourselves. We still have a problem of skills mismatch and lack of practical exposure. If you are lucky to be at academicity, that may not be your problem, but you see that my examples are talking about the typical experience. We are still graduating too many engineers who have never been on a real site, never touched a real budget, never solved a real community problem. Final year projects are brilliant. I have supervised them, many of them. But too many end up bound in hardcover and placed on a shelf. The student gets A, the community gets nothing. The student then graduates and industry says, they are not ready. The graduate says, there are no jobs. Both statements can be true at the same time, and that is the clearest sign of a broken pipeline. That is not just an education problem, it is a pipeline failure. Stage 4, the launch, the transition to career. In Ghana, that would be the national service, right? I expect there are similar experiences elsewhere in Africa. This transition to career should be the strongest joint in the pipeline. For many engineering graduates, it is the weakest. Posting a civil engineering graduate to file papers in an office is not nation building. It is talent wasting. When we do that, we tell the graduate, what you learned does not matter here. Many believers, and they leave. They go to Canada, to Germany, to the UK. We call it brain drain, but the brain was already drained the day we wasted their success here. That is the reality. We lose them at 10, we confuse them at 16, we underprepare them at 22, and we underuse them at 24. If a water engineer designed a pipe like this, we would sack him or her. Yet, this is the pipeline we have built for our human capital. Now, let's balance the story. Because the African reality is not only about gaps. Not all doom and gloom, no, it's not. It is also about remarkable success. In Kenya, M-Kopa Solar has connected over 1 million households to affordable solar energy using pay-as-you-go systems. Children now study at night. Families save money. Jobs are created. This is engineering solving real problems at scale. Similarly, the Lake Turkana Wind Power Project, Africa's largest wind farm, supplies about 12 to 17% of Kenya's electricity. That is what happens when engineering leads intention. Second example, across the continent, startups are developing AI-driven irrigation systems that reduce water use by up to 40%. Others are recycling wastewater, achieving up to 76% reduction in water usage. Engineering is already transforming agriculture, sustainability, and livelihoods. Third example, through initiatives like the Africa Prize for Engineering Innovation, sponsored by the Royal Academy of Engineering UK, African engineers are developing real-time water quality monitoring systems, battery-powered transport solutions, renewable energy storage devices, and smart agricultural technologies. These innovations are solving challenges in healthcare, agriculture, energy, and urban infrastructure. The talent is not missing. It is the pipeline that is. Next example, African-built platforms such as Paystack and Flutterwave, two of Africa's biggest fintechs, have transformed digital payments across the continent, attracting billions in investment and enabling businesses to grow globally. This is engineering not just solving local problems, but competing globally, starting from Africa, going across the world. Last example. Finally, where technical and vocational education works, graduates often have higher employability because they are job ready. Many go on to start businesses, driving local economics and job creation. Countries that invest in skills-based training see stronger workforce outcomes. The question now is, how do we rebuild the broken pipeline so that we can do even better? We rebuild it the same way we build anything that must last, from the foundation up, with the right materials and with every part connected. We must build a pipeline that starts early with curiosity, connects learning to real-world application, bridges school to industry, and leads directly to meaningful careers. This is because a child with curiosity must meet opportunity. A student with knowledge must gain experience, and a graduate with skill must be deployed effectively. Let's look at 4 practical solutions to the problem of the broken pipeline. Solution number 1, start at the basic level and start now, immediately. We must demystify engineering before fear sets in. Engineering is not calculus. Engineering is problem solving. A class 4 child who designs a better way to carry water from the stream without spilling is doing engineering. Tell her that. Praise it. 3 actions will help us here. First, put tools in the hands of children. No, not laptops for everyone on day 1. No. Start with low-cost kits, batteries, light bulbs, wires, locks, syringes, plastic bottles. The Ghana Association of Science Teachers and groups like DEX Technology and Practical Education Network have already piloted kits that cost less than 50 Ghana cedis per pupil. Let's scale them. Second, train and retool the teachers. A 1-week STEM boot camp every vacation for every junior high school science and math teacher will do more for Africa than another white paper. This is what we're doing at the Helping Teachers Teach Mathematics Conference. We need more of such initiatives. If we can train electoral officers in 2 weeks, trust me, we can train teachers to run a water filter experiment.
Oh yes.
Yes. Third, bring engineers to the classroom. Every district should have an engineers in schools day once a term. In Ghana, let a Greco engineer tell junior high school students how math keep their lights on. Engineer, chair. Send your ECG people to the classrooms. Let a woman engineer from the Ghana Water Company tell girls that pipes and pumps are not men's work. If a child cannot see it, she certainly will not be it. And let us teach the why in our languages. The concept of force exists in Twi, Ewe, Gan, and Dabani. Let's start there. If they can't speak the English, go to them with the local language. The English label can come later. Understanding must come first. Solution number 2. Let's make senior high school TVET and university the bridge, not the bottleneck. At senior high schools and in our technical institutions, every student must touch the real world before they choose a career. I propose senior high school industry days as a policy. Once a term, every senior high school science and technical student should spend a day at a real site, a road project, a food processing plant, a tech hub. In Ghana, said ECG, VRA, Ghana Water Company, and the Association of Ghana Industry should all be part of this. Go and adopt a school for goodness sake. We must also fix the internship gap. Waiting until the final year of university to do an internship is like teaching someone to swim by giving lectures and then throwing them in the Volta River in the final year. It doesn't work. Let internships start at 16. 2 weeks in first year of senior high school, 1 month after senior high school, and every long vacation at university. The work does not have to be complex, no. Watching a technician fix a transformer teaches more than any textbook diagram. At the universities and technical universities, we need 3 changes. First, co-teaching. Every core engineering course should have at least 20% contact time with industry professionals. Second, co-owned projects. Final year projects must solve problems submitted by district assemblies, companies, or NGOs. If the project works, the partner funds implementation and hires the team. Is that too bold? Is that too much to ask? Third, we must reward faculty for impact. Promotion should weigh community solutions alongside journal papers. A ventilator designed at the University of Ghana or Academic City that saves lives at Kolegu Teaching Hospital should count for something in promotions. All right, solution number 3, weld the last joint, career entry. And here, let me start with a joke. We've been joking that Ghana is the one place where somebody can go study engineering for 4 years and for national service be posted to a chopper to grind for food. The transition to work for engineers must be an engineering service. Post civil engineers to feeder road projects, post electrical engineers to district ECG officers. Say, today I have your case. Post chemical engineers to water treatment plants and food factories. Post biomedical engineers to hospitals if they fancy clinical engineering careers. Let them be supervised, let them be paid, and let them be hired if they perform. Government has a role. Get Fund and Ministry of Education must ring-fence money for applied labs, not just lecture halls. 1 functional power systems lab at each technical university will create more jobs than 10 new auditoria anywhere. Provide tax incentives to any company that takes more than 20 interns a year and converts 30% of them to full-time staff. Review TVET curricula every 3 years, or even more frequently, with industry, not every 10 years. No. Industry, you are not a bystander, and I hope there are some industry players here. You are the main beneficiary of this pipeline. Don't wait for ready-made graduates. Help us to make them. Second, your best engineer to teach 1 course a year when you adopt a school. Submit your ugliest operational problem as a student captain. The company that invests in a 19-year-old intern today is building a 29-year-old plant manager. Alumni, especially those of you in this room from Legon, KNUST, UMAT, Ashese, ACT, our technical universities, you drank from this well. Send the bucket back down. Mentor 10 students. Fund 1 scholarship. Fix 1 lab. We need you to support. And to the students here, how many students are listening? Okay, I have a message for you as well. Please stop asking, will this come in the exam? Somebody answer. students who search for past questions first day of the semester. Please start asking. Will this work in Choco when the tide is high? Your degree is not an escape ticket. It is a license to build. Africa does not need more engineers who can pass exams. Africa needs engineers who can do. The doomsday you grew up in, the flooding you walk through, the traffic you sit in, those are not complaints. They are your design briefs. I hope you have heard me. All right. So let me try and put some thoughts together for my conclusion. We did not wait for the world to give us kente. We wove it, thread by thread, with patterns that tell our story. Our engineering future will not be given to us either. We will weave it, child by child, project by project, from basic school to career. The African reality is not a limitation, no. It is a design challenge. And we, as engineers, we solve design challenges, don't we? The constraints are real, yes. Budgets are tight. Lights can go off, ECG. Data is scarce. But every great engineer in history worked with constraints. They are not excuses. They are parameters. So let's agree today. No more talent wasted. No more problems unsolved for lack of Ghanaian or African engineers to solve them. From the classroom in Wa to the innovation hub in Accra to the energy grid in Nairobi, let the pipeline be strong, wide, and unbroken. The foundation is us. The time is now. Let us build. Thank you very much for your attention.
Please, if we have any questions for Dr. Kaufmann, this is the time. Can we answer? First question? Okay, let's start from the two ladies here.
Thank you so much, Prof. My question is from the more or less like the last thing you said to the students about them not asking what will come out of the exams. I want to hear your thoughts around this. I think sometimes our students are in the mode already from the basics because we celebrate the positions from the primary to the high school, those that actually pass the exams. And those exams assessment also do with looking for past questions so that they can pass those exams. So it seems as if that mindset goes into the tertiary education system. What are your thoughts around a mindset shift through an assessment that sees problem solving as core, especially for engineering? It might seem a bit complex, but what are your thoughts around where we can start from? Because I think the problem actually comes from the basics and how we build our children instead.
Well, thank you for such a event for us today. So, as a biomedical engineering student, I sometimes feel there's more emphasis on theory than hands-on experience. So, aside internship, what practical steps can students like me take on my own to become industry ready before graduation?
Thank you, Prof, for the delivery. I'm going to speak from an experience I had some few years back. I'm a student of the Kumasi Technical University, and as part of our teaching, once a particular semester, we are taken to industry to see how they operate and how they conduct their processes. We went to this oil refinery and we saw PLCs. And when I was in year one, I went to attend a program and we worked on the PLCs. We actually won. So we learned how to program them, we talked about the various modules. But when I went there, I saw that it was the Indians that were programming them, and that when they leave, they love the PLCs. And those engineers from my school were just sitting there and watching the 3D animations and clicking some buttons when they turn red. And on further investigation, I was told by one of them that if I wanted to, interact with the PLCs, I have to come on a day where the Indians are around and where they can teach me those things. My question is, why are we not trusting our local engineers with these? And if you're not giving them the opportunity, how do we, gain these skills that we're talking about here? Thank you very much.
Excellent questions. Thank you so much for these questions. Let me take them in order. Our first young lady says, is the issue not coming from our basic schools? We are used to passing exams and we celebrate them. You are very right. It comes, see, this is what we're talking about in pipeline. None of these academic institutions is in isolation. It is a pipeline, right? And we are very good at it. I have been using Newton's first law as my example for trying to explain how things work when it comes to these matters. Unless you bring in an external force, it will continue to be the same. It is human nature. It is a law of nature, is it not? Okay? So take the young person that went to basic school. They do well on exams. Their parents praise them, right? When CEEA time comes, you reproduce what you have been given and you pass nicely. And because you have good grades, you go to a good junior high school, senior high school. You do well in WASI. We all do it. We have cut-off points, right? So for the best programs, the one that is able to answer the questions on the WASI very well, they are the ones that get admitted to university. And then suddenly they come to university and I'm telling them, don't look for past questions. Don't ask what is the exam going to look like. You have to put in an external force to do it. Usually for my students, and I have a couple of my students here, I think, I am the external force. Come to my class, there is no way you will find more than 5% of my assessment asking you what is this for you to reproduce anything. If you are not able to do problem solving, you will not pass the course, right? Each of my courses has a practical component. There is a course project. I'll come to you, the young lady, environmental engineering students, and I'll expand on that, right? So we build these people, actually we are selected for people that pass exams in our educational system. If you are focusing on something else, you may not get the chance to continue your education, right? And this is something that I have been talking a lot about. If you find my interactions with our examination bodies or even with our own colleagues who set exams, your students are very bright. They will adjust to you. In fact, they study us as much as they study the course material. They know what you are bringing next. So, yes, it's true. So we have to change the way in which we set our questions. The challenges have to do with, a lot of the time, class size. An activity, so for example, you can design a beautiful assessment that involves practical conversations, an oral exam. If you have a 160 class size, how do you do this realistically? This is where technology may have to come in, right? Some kind of personalized learning that is possible even outside of the class, for you to have an idea how well you are doing, an opportunity to generate problems that require critical thinking and problem solving. It is possible to do, like I said, my courses are not the typical. If you just come and memorize them, in fact, they accuse me of giving slides that are not complete. If you just focus focus on the slide, there's no way you're going to write. So we as educators, those of us who are educators here, it is our responsibility to do the extra work. But the challenge then comes, if you spend all your time, these meaningful experiences come at a cost. It will take you away from your research. Meanwhile, there's a journal publication that you need to get promoted. So how will you balance that? This is why I also mentioned that if you make meaningful impact, that should also count for something. You see, so it requires a rethinking of our whole system, that whole pipeline, to ensure that at the end of the pipeline, we have the products that we actually want to get. Okay. So yes, you are right. It's because of the way in which we assess. We have to start with, even at the basic school level, what kind of assessment, because our students are very bright, they will work that thing out. They know that that is where the reward is, and that is what they're going to do. It's human nature, isn't it? And we have very bright students, so that's exactly what they're going to do. So each of us must commit to being that external force to change the way things are going. All right. The biomedical engineering student. Biomedical engineering training is expensive. I hope you know that. If you want to teach all the concepts practically, the kind of lab you will need to build, the kind of collaboration you have to have with industry and with hospitals is incredible. But we should aim towards doing that. However, there are certain things that you can do yourself. What practical things can you do? I tell my students, if you go to a course and there is a course project, I know many of you will be very unhappy because the course lecturer is giving you more work than necessary. That course project will ask you to do things outside of class, and you usually don't like those lectures, right? But let me tell you, those are the lecturers you should thank. And many times, for my students, I find out that when they finish school and they are putting out their CV for the job, for the graduate school opportunity, it is the course projects that they had with me that they list as their experience. The same thing they lambasted me for giving them too much work. So if the course lecturer gives you a project to do, the project, they may not give you a topic. You may have to go and find that topic. By the way, engineering education is also about the ability to identify problems. So the ones that give you topic, they are not doing you a favor. Trust me. The one that tells you go out to break a problem, let's talk. That's the one that you should be thanking. You should thank the educators that give you such opportunities. If they don't give you the opportunity, it is your responsibility as a student to have a project going at every stage of your academic life. It can be one project you take on in first year that you build on throughout your academic life as an engineering student, or you can have different projects that you're doing at any moment in time, building on the theories and the concepts that you are learning in class. Education is not the responsibility of just your lecturers or the school. It is your own personal responsibility to make yourself relevant and marketable by the time they're getting out of school. In fact, it's your responsibility to anticipate what the world looks like by the time they're graduating so that you can fit into that world. And not all the experiences can be given to you in class. Okay? So learn the things that are very important to learn with the help and support of a facilitator. See your lecturers as facilitators to help you to learn. If it's easier to talk to somebody and learn it, use that opportunity to do it, because when they release you into the world, when you come back, they will charge you consultation fees. I hope you get me. Mm-hmm. So take advantage. Sometimes opportunities are advertised, and I'm amazed so many opportunities out there to get practical experience, and students don't take advantage. I hope ACT students are not like that. Yeah. Because they'll tell you we are busy learning. And I ask, what do you understand by learning? You're busy learning. So you cannot take an opportunity, a company is offering a course in something practical, and you are too busy learning to take advantage. Really. Anyway, so the opportunities are there. The main thing is to recognize that you cannot get everything in the context of the classroom. It is your responsibility to identify these opportunities and to create some opportunities for yourself as a student as well. Okay? All right. And then the KSTU student who went on field trip, where is he? And found that yes, it's not the Ghanaian engineers who have opportunity to do things. It happens in many places and you know. This is because, go to the hospitals, right? The biomedical engineering units in our hospitals. We train biomedical engineers in Ghana. They become clinical engineers in hospitals. When they get there, sometimes even the decision to acquire a certain piece of equipment, they are not consulted. It is someone else making the decision to bring in the equipment. When the equipment comes, because it is imported, it comes with certain agreements, service agreements, or even operational agreements. The people that supply the equipment are the ones that must touch the equipment. Everybody else must be there doing the backend that you solve. And so, people do not gain experience doing this. It's because of the agreements and the methods that we use to acquire equipment. So think of it this way. What if we truly, really value the engineers that we produce? We trust them. We may even encourage people to produce the equipment locally. If a company produces that piece of equipment here in Ghana, why would they bring a foreigner to come and operate it? Then we must think about the legal and the government structures that surround acquisition of equipment, right? If we insist on local content and we require our people to also learn and use and produce, when somebody is making a decision to acquire something, hopefully they will remember that we have those laws that are really right. You are in a position to get to that level. I hope when you become somebody very important making these decisions, you will remember this question you asked and behave differently. Thank you.
I would have loved to take more questions, but Professor Kaufmann, a bonus question for you.
Okay, it's not really a question, but before I come to this, I want to thank you so much. I'm not an engineer, but this is perhaps one of the simplest explanations I've had in my over 3 decades of engineering. Yesterday I was telling my colleague here and another colleague that if I had lived elsewhere in the world, I would have done more complex things because my mind loves complex things. But as we're growing, my introduction to science was more of medicine and at first, like you said, car. So if you loved anything complex and you didn't go through cars or medicine, then it meant to do other things. I've loved math, but I couldn't probably use it as much as I can. I'm on Whipple Authority, and until joining, I appreciated engineering very much because 2 years back, when he and I had to document our training and maintenance, coupling one of our generators. We spent 3 to 4 months with engineers coupling everything and reassembling it. And it was a very exciting thing for me. But I mean, I can do that now, so I enjoy being with engineers and what they do. Now to my charge to you, Prof, and to other teachers, that when you say the students should not ask what is coming into the exam, it's from teachers. A teacher walks to the class, a lecturer, and the first day of class, they are telling you how they're going to mark your exam, why you should pass this, and if you don't, you're going to fail. So the first introduction the lecturer does to a Form 1, the first year student, is putting fear in you, is telling you to memorize their handout, and the way they want you to write it
to the extent that in one of my MBA class, and when it's a sad situation, that someone was marked down for exchanging the word remuneration for salary at an MBA class. And that's how bad it is. And I sat and I thought of it. It's semantic, it's potato. Remuneration and salary are the same thing, depending on where you're standing. So this is what most of the times we are faced with. Students, when you're in school, that's what you're faced with. To the extent that even at very higher education, lecturers are still doing that. So my charge to you, as you make engineering very easy for all of us and for younger people, is for your colleagues to make it more practical, to stop hanging exams on students' necks, because exam is just a part of all we are doing. A lot of things that we failed in because we could not recollect and write, we are using in our lives. So sometimes it is very important.
So that was the answer we wanted. Prof, you have any?
Yes, that was the bonus. Oh my goodness. My colleagues are here, I'm sure they have heard. It's unfortunate. You see, somewhere in my keynote I mentioned that you cannot give what you don't have. There are many of the educators, and I put educators in quotation marks, because if you're an educator and you're doing this, you are obviously off track, right? The world has changed, but that is how they were taught. Some of them, it is a coping mechanism, right? So somebody goes to a school, first of all, they go and make promises that the school, we have very few teachers in certain disciplines. Okay, so you can find an agricultural science graduate teaching physics. They went to give promises that they can teach physics. They get into the physics class. The best way, you see, there's a lot of ego involved in this. You have to put yourself in the position of a teacher before I come and talk. A teacher goes to class, the credibility is at stake. Every class, every hour, every minute. They are not in their position of strength. And so the easiest way, and it used to happen more, I thought it was over, but it's obviously some things are still going on. The easiest thing to do is to intimidate your class. Okay, this thing is very difficult. Most people don't understand it. Then you'll be moving on. Because it's very difficult, nobody will ask you a question and you are free. Please, if you studied agri science, don't lambast me later. It was only an example. But that is what we had in the system. Things have to change. In fact, in university now, most universities I hope have adopted this. The first day of class, you are supposed to hand out your course outline. That outline is your contract with the students. The students should see what the learning outcomes are supposed to be. Because it is a contract between you and the students, you will be asking questions along to check to see whether you have achieved those learning outcomes. Please, I hope you get me. So you, the lecturer or the teacher, you're supposed to design experiences to help achieve the learning outcomes. Hopefully, you didn't do it in isolation. Somebody oversaw and decided that the outcomes are realistic ones. In that case, the student should not even be asking what is going to come as a question, because they know what is being tested. Please, do you get where I'm coming from? So, for example, I tell my students, when you are able to set your own questions to satisfy what the learning outcomes for the course are, that's when you have understood the course. You don't need me to even set questions. And yes, unfortunately, unfortunately, some people have found, I have seen exams like this. They'll take a whole passage from a textbook, blank out some words, like salary, remuneration, and students are supposed to reproduce that in their passage for marks in 2026. Come on. As students, you also have a part to play. When the time comes for evaluation, and I hope evaluations are going on, what do you say about these lectures? Because you like memorization, you were selected, you were pre-selected because your ability to memorize. So you like such exams. You get A or B, then you keep quiet. And this continues, right? If you were to speak out, that this is the kind of experience we want, because it's the kind of problem we want to solve in the real world. In the real world, who's going to give you a passage to fill in? Maybe if you ask for what you are due, you will get better. And according to the ones who actually make the effort, we have to recognize and reward them. We are humans after all. If there is no reward system in place for putting in the extra work to set a realistic exam that actually tests students' ability, why should we continue when we could be doing a research for promotion? So yes, we are sorry.
Okay, shall we get on? We have a gift for you. You don't come to academic city and leave just like that. So, our chair, Engineer Dr. Muna, you will please present the gift to Dr. Kaufmann. Thank you. So, if I go to the middle, because the camera will also do its part. Okay. All right. As you hold it, please hold it. Prof, please, you have to join. Yeah, we want the picture to be more engineered.
Oh boy.
Once again, thank you, Professor Kaufmann, as she sits down.